Um, Ameba is a topology optimization software based on a technique called BESO. And first of all, I would like to show the Ameba team. This is really a dream team. You can see on the screen these young boys. We have 3 engineers and 3 architects. And if without me, the average age would be around 22. So my presence has almost doubled the average age. And
Mike?
Can you see the movie?
No, it's coming.
It's not moving. Anyway, Amoeba is actually a type of single-celled organism capable of changing its shape according to its different environments. It's unfortunate the movie is not showing. Amoeba is actually changing shape when it has different surroundings. And so inspired by the amoeba in nature, we were thinking whether we could use this kind of concept for architectural or structure designs. So when we gradually removing inefficient material from the structure, or we add material to the most needed parts, we can optimize a structure design like what you see on the screen. So this concept was developed around almost 30 years ago by my team. We call it a bi-directional evolutionary structure optimization. And in short, it's called BESO method. If you see what's happening on the screen, so we are trying to develop a bridge from a very simple initial design of a beam and 4 columns. So using the BESO concept, it can transform a very simple initial design like the one on the top into a beautiful structure at the bottom. So we are getting an arch bridge, and on top of that, we have these tree branches in order to distribute the load in the whole structure evenly. So we're not making a small local modification of the initial change. We are actually creating a completely new concept of an arch. We have applied our technique to many different structures and projects. And this is an example I did with Professor Mike Xie when he was doing the church for Sagrada Familia. So this is a passion facade. Using our BESO technique, we can actually reproduce many of the shapes Gaudi designed in Barcelona. And Ameba is a simple plugin. So we are taking advantage of the modeling and meshing capability of Rhino Grasshopper. And we use cloud computing in order to have very fast computational speed. And the whole algorithm is based on the bi-directional evolutionary structure optimization algorithm originally proposed by my team. So I'm going to show you some examples from Ameba, especially those examples from the students in the Digital Future workshops. So this is a student from this year's student. He's actually an undergraduate student in his 3rd year in architecture. So from using Ameba, he's able to generate a beautiful form like this for an art museum. The next one is by the same student, an undergraduate student. So Ameba would consider the loading conditions and boundary conditions, and for the given condition, then it will generate these forms by removing the inefficient material and then strengthen the critical parts. So it's not a purely artistic imagination. It's a performative design based on structure performance. So this is from a student from last year, Digital Future, and he used Ameba to generate a wooden pavilion, again, based on those given supporting conditions and the loading for a wooden pavilion like this. There's many people use our Ameba tool to design furniture. So this is 2 different chairs by 2 students. If you come to Melbourne and visit my office, you will see these tables designed by my students. So using Ameba, and we can remove those inefficient material to create those organic shapes. And the two female students joined our group last year in Tongji, and they designed these high heel shoes for themselves. And this is an unmanned aircraft designed by my student. And this one can actually fly very well. We flew in our campus several times. It is very light, and the whole airframe is 3D printed in one piece. And I'm going to show you 3 examples from this year's Digital Future workshop. So in the past 5 days, one group designed this beautiful children's slide. And the next group, this is a pavilion, and with tables and chairs and all these pieces were designed using Ameba software. So it really reminds us of those columns in Gaudi's Park Güell. And this one is very interesting, again, from the students from this year's workshop. So they tried to redesign this Eiffel Tower. So if you look at the original Eiffel Tower, I think that's a product of Industry 1.0. And on the right-hand side, we are really going into Industry 4.0 with the latest digital design technologies and advanced manufacturing techniques. And I'll show you a very short video about Ameba software. Thank you very much, everyone.